Good morning to all. As we have started the chapter probability, so we know about the intersection. Intersection so A intersection B, what it means? Look at this. A intersection B means here we have a set of A, set of B, and why we are taking this set like this. So A intersection B means out of these A and B, what are the common things are there? We are including in that A intersection B. Means suppose I have a set of A is equal to A, E, I, O, U, and set B including A, B, C, D, E, and F. Now here we are taking that A intersection B. So A intersection B means the terms which are common in between these two sets. So what are that? A, E, A, E. Therefore, A intersection B means here set of A, E only. Okay. Now, next. What is A union B? So A union B means here if A is set of 1, 2, 3, 4, 5 and B is a set of 3, 4, 5, 6, 7 and 9. Then we are taking that A union B. So A union B means the terms which are including in set A and B we are taking combinedly. But if repeated terms are there, then we are taking only one time. So here 3, 4, 5, these terms are repeated. So A union B, it includes 1, 2, 3, 4, 5, 6, 7 and 9. Okay. Do you understand this? What is the A intersection B and what is the A union B? Okay. After this, we know about that addition theorem. Probability states that for a given set of events A and B with probabilities P of A and P of B. P of A and P of B. So P of A union B, P of A union B is equal to probability of A plus probability of B minus probability of A intersection B. This is the statement of addition theorem, that one part, that is property of that addition theorem. Next, if A and B are mutually exhaustive events, then P intersection then we are taking that P of probability of A intersection B is equal to probability of A into probability of B. And if A and B are mutually exclusive events, then probability of A intersection B is equal to 0. Probability of A intersection B is equal to 0. In other words, for mutually exclusive events, probability of A union B is equal to probability of A union B is equal to probability of A plus probability of B. Okay, now we are going to see some examples. Look at this first example. A stationery box contains 3 red paper clips 4 green paper clips and 5 blue paper clips. One paper clip is taken from the box and then replaced. Another paper clip is taken from the drawer. What is the probability that the first paper clip is red and the second one is blue? Okay, so look at this. In this example, we are taking this as, here I am going to solve that first example. Probability of red, first red, blue, which is equal to probability of red into probability of blue. Probability of blue. Suppose here consider this red as A event and blue that is B event. So P of A into P of B. Which term we which theorem, which property we are using here? If A and B are mutually exhaustive events, then probability of that given things is equal to P of A into P of B. Okay, so consider that given probability of red. Total, how many clips are there? A stationery box contains 3 red paper clips, 4 green paper clips, and 5 blue paper clips. And one paper clip is taken from the box and then replaced. Another paper clip is taken from the drawer. What is the probability that the first paper clip is red and second one is blue? So there are total 12 clips are given. So out of that 12, 3 are red. So 3 divided by 12 into blue. How many blues are there? 5. 5 out of 12, which is equal to 15 divided by 144. So 15 by 144, it gives 5 divided by 48. So probability of red and then blue. So that there is a 5 by 48. The next example. A single card is randomly selected from a deck of 52 playing cards. What is the probability of choosing a queen or a heart? Okay, so there are total 52 cards are in pack. So out of that 52, probability of choosing a queen or a heart. So here we are using addition theorem. So here P of queen or heart is equal to, so probability of queen plus probability of heart minus probability of queen of heart. So which is equal to probability of queen, that is 4. Out of 52 cards there are 4 queens. Out of 52 cards there are hearts. How many hearts are there? 13. And queen of heart there is only 1. So 4 divided by 52 plus 13 divided by 52 minus 1 divided by 52. 1 out of 52, 13 out of 52, 4 out of 52. So calculating this, 13 plus it is 17 divided by 52 minus 1 upon 52, which is equal to 16 divided by 52. So 16 divided by 52, if we are dividing by 4 in numerator and denominator, so it gives 4 divided by 30. So there is a probability of queen or heart. It will be 4 by 30. Okay. Then next example. the probability that it is Tuesday and that a Raman is absentee, that is 0.03. Since there are 5 college days in a week, the probability that it is a Tuesday is 0.2. What is the probability that Raman is absent given that today is a Tuesday? Now, in this example, Tuesday probability that is on Tuesday and that Raman is absent, that is 0.03. त्या ठिकाणी डिरेक्टली 0% वगैरे काय दिलेलं त्याने डिरेक्टली 0.03 आणि 0.2 दिलेले पर्सेंट ते out of that days 5 days. Okay, so here we are finding out probability of Raman absent on Tuesday is equal to probability of Tuesday and absent, probability of Tuesday and absent divided by probability of Tuesday, which is equal to 0.03 divided by 0.2, which is equal to how much? 0.03 by 0.2, it is near about 0.15. Okay, now go for the next example. 2 dice are thrown simultaneously and the sum of the numbers obtained is found to be 8. What is the probability that the number 5 has appeared at least once? Here 2 dice are given and they are thrown simultaneously. The sum of the numbers obtained is found to be 8. त्या ठिकाणी त्याची addition ही 8 असायला पाहिजे. आणि what is the probability that the number 5 has appeared at least once? Okay, so in this example we are taking as sample space yes. Consider sample space yes. Yes. So for this problem, sample space yes would be all the possible combinations of numbers on the dice. Okay, therefore yes consists of so that is 30 Sorry, 36 events are there. Now, event A indicate the combination in which 5 has appeared at least once. Suppose event A indicates the combination in which 5 has appeared at least once. And event B indicates the combination of the numbers which sum up to 8. Which sum up to 8. Okay, so let us write that A, events of A, event A is equal to 5 appeared at least once. त्याची सेट घ्यायची तिथं. So 5-1, 5-2, 5-3, 5-4, 5-5. And last one 5-6. Next possibilities 1-5, 2-5, 3-5, 4-5, 5-5 appears 2 times, so we are taking as a 1 time. Okay, then 4-5 and next is 6-5. Okay, then event B. I will write here only. What are the possibilities? B is equal to 2, 6, combination that sum up to 8. So 2, 6, 3, 5, 4, 4. Next possibility, that is 5, 3 and 6, 2. Check out that. Event A indicates combination in which 5 has appeared at least once. Okay. And event B indicates combination of the numbers which sum up to 8. So here we have these two sets. Now probability of A is equal to total events are 36, and out of that 36, how many possibilities are there? Probability of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Out of that 36 events, there are 11 possibilities. And for event B, probability of B is equal to, out of that 36 events, what are the possibilities? 1, 2, 3, 4, 5. There are 5 possibilities. Okay. Therefore, P of A intersection B is equal to, probability of A intersection B is equal to, which one is the common term here? What are the common terms in between A and B? Which probabilities? There are 2 probabilities. Which are they?
5, 3 and 3, 5.
Yes, 5, 3 and 3, 5. So here P of A intersection B is equal to 2 out of 36. Okay, so this is the answer. Okay. Now next, if A and B are 2 independent events, if A and B are two independent events with P of A is equal to 0.6 and P of B is equal to 0.3. Then P intersection P of A intersection B. So P of A intersection B is equal to. So here we are solving this since A and B are independent events. ओके आता या ठिकाणी A डॅश आणि B डॅश कन्सिडर केले त्यांनी. आता A आणि B हे दोन इंडिपेंडेंट इव्हेंट्स असतील तर A डॅश अँड B डॅश हे सुद्धा त्याचे काय असणार आहेत इंडिपेंडेंट इव्हेंट्स असणार आहेत. सो वी आर टेकिंग दॅट P ऑफ A डॅश इंटरसेक्शन B डॅश is equal to P of A dash into P of B dash, which is equal to A 0.6, B 0.3. So here we are getting that answer. How much? Yes. आता हे A dash म्हणजे काय सांगतो तुम्हाला इथं हा सपोज A is equal to 0.6 आहे. Out of 1 A is 0.6. Out of 1 A is 0.6. Then A dash will be remaining 1 minus 0.6 म्हणजे 1 minus P of A. Here we are taking that A dash is equal to 1 minus P of A, which is equal to 1 minus 0.6. हे फॉर्म्युला तुम्हाला लिहून दिलेत मी आधी, which is equal to 0.4. And similarly B dash is equal to 1 minus probability of B, which is equal to 1 minus 0.3, which is equal to 0.7. So here probability of A dash, that is 0.4 into 0.7, which is equal to 0.28. त्या ठिकाणी हा फॉर्म्युला लक्षात ठेवायचा. A dash is equal to 1 minus P of A, B dash is equal to 1 minus P of B. Okay. The next example. An old person forgets the last 2 digits of a telephone number. An old person forgets the last 2 digits of a telephone number remembering only that these are different dialed at random. Remembering only that these are different dialed at random. The probability that the number is dialed correctly is. What is the probability? What is probability that the number is dialed correctly. Okay. So what is given? An old person forgets the last two digits of a telephone number, remembering only that these are different dialed at random. The probability that the number is dialed correctly is, we have to find out that. So last two digits can be dialed. The last two digits can be dialed in, that will be 10p2, which is equal to how many ways? 10 permutations in two ways, 10 probabilities in two ways. So it is 10. What is the formula of probability permutation? 10p2. How we are taking that? 10p2.
10 factorial of
NPR, yes, 10 factorial divided by 10 minus 2 factorial, na? Which is equal to 9, 10 into 9 into 8. 8 factorial cancel. So 10 into 9, it is 90 ways. Okay. Now, out of these 90 cases, there are 90 cases total. So out of these 90 cases, only one case is favorable. Hence the required probability. Hence the required probability is equal to only one case is favorable. So it will be 1 upon 90. There is the correctly dialed only one times out of that 90 ways. Okay. Next example. If A and B are two events, such as if A and B are two events, such that probability of A, P of A is equal to 0.5, probability of B is equal to 0.6, and P of A union B, P of A union B is equal to 0.8. Then find P of A by B. Okay, P of A by B. So look at this. Since what is given here, P of A intersection B is equal to P of A intersection B is equal to P of A plus P of B minus P of A union B. Okay, which is equal to 0.5 plus 0.6 minus 0.8, which is equal to 11 minus 8, that is 0.3. It is P of A intersection B. Now we are finding out P of A by B, probability of A by B, event A by B is equal to probability of A intersection B divided by probability of B, which is equal to 0.3 divided by 0.6, which is equal to 1 upon 2. So here we are getting that probability of A by B. Next one example. By using shortcut method, we are solving it. I will write here first a problem of chemistry is given to four students. That are P, Q, R, and S, whose chances of solving it are 1 by 3, 1 by 4, 1 by 5, and 2 divided by 15 respectively. Then find the probability that the problem will be solved. That the problem will be solved. Okay. Let us start to solve this. So required probability. Out of 1, a problem of chemistry is given to 4 students, PQRS, whose chances of solving are 1 by 3, 1 by 4, 1 by 5, and 2 by 15 respectively. So we are taking required probability, which is equal to total out of that 1 minus 1 by 3 into 1 minus 1 by 4 into 1 minus 1 upon 5 into 1 minus 2 by 15, which is equal to 1 minus here it is 2 by 3 into 3 by 4 into 4 by 5 into 15 minus 2, that is 13 by 15, which is equal to, calculate this. 1 minus, first make the multiplication, and then subtract from 1. So it is 1 minus 2 by 3, 3 cancel, 4 cancel, 2 into 13, that is 26, 15 into 5, 75, which is equal to 75 minus 26 divided by 75. How much? 75 minus 26. It is 49 divided by 75. So here there is the probability of 49 by 75 that the problem will be solved. Okay. Please put your roll numbers in chat box. Getting my voice? So shall we end here?